Section 36, separation of variables. I say this section is really important because it really is the only section that we take all year that really deals with differential equations, and differential equations will always be one of the AP problems on the AP test. And every time I've seen it, it's been worth 6 points to actually solve a separation of variables problem. So the goal in this is just to find what y equals in the original equation. And you start with the derivative equation. So, for example, in the problem here, you have the derivative times 3 equals y times x to the fifth minus sine of x. So our real goal is just to find a y equals equation that represents this differential equation. So I'm just going to do 5 examples in this video. I'm going to start with the first one here. So by separation of variables, it means put all the y's on one side, put all the x's on the other side. So I'm actually going to move the y over to this side, and I'm going to get dy over y, and move the dx over to this side. I also keep a 3 over here, so I'll just throw it there. So I multiply the dx over to this side, and I get x to the fifth minus sine x dx. Cool, that's the separation of variables stuff. My variables are now separated. Now I need to integrate both sides, so I'm going to throw some integrals on here. And here I get 3 natural log of y. And on this side, I get x to the 6 over 6 plus cosine of x. And then plus c. We can put plus c's on both sides since technically there are integrals happening on both sides, where on this side we're doing the integral with respect to y, this side with respect to x. But a plus c on both sides is the same as having a plus c on just one side, because you could always subtract the c over and you'd just have a different c. So we just put it on the x side. It just makes things easier. Alright, well I gotta move the 3 over because I need to get the y by itself now. And so I divide by 3 and I get x to the 6 over 18 plus cosine of x over 3 plus c. Now to undo natural log, I gotta do e to the power of both sides. And so I actually get y is equal to e to the x to the 6th over 18 plus cosine of x over 3 plus c. But I'm not done here because I actually have to deal with the c. And the way we pull out c's is anything added up here I can rewrite as e to the c multiplied out in front. So like this, y equals e to the c times e to the stuff with variables in it, e to the 6 over 18 plus cosine of x over 3. And this is just a new constant, so I just rewrite it with a new constant, y equals c e to the x to the 6th over 18 plus cosine of x over 3. And that would be a good way to leave our final answer right there. Alright, next one. This one's much simpler looking. Let's see if it stays simple. So this is one where we actually have to find the particular solution, which means we have to find c after we integrate. But it won't be too bad. So let's get the x's and y's on the same side. First I divide x over on this side, and I multiply the y over this side, so I get y prime equals x over x, which is 1. Okay. Now I have this problem. I don't have a dx, so how would I integrate? Well, it turns out y prime is dy dx, so actually we do have a dx in this problem. So I need to multiply it to the other side and get y dy equals 1 dx. Now I can integrate. Integral y squared over 2 on this side, and x plus c on this side. Okay, so questions I ask always ask for y in terms of x. So you need to solve for y, not y squared. So while we have y squared here and it's great, we need to keep going until we get y. So I'm going to multiply 2 to the other side. Y squared equals 2x plus a new c now. And then I have to square root both sides because I got to get y by itself. And so our answer is either going to be this or it's going to be this with a negative square root. But from our initial condition, we know which one it is because the output of our function is positive. And our output can only be positive if we use this guy. So I throw this one out. And now I just need to solve for c. So I plug in 0, and I get 5 is equal to the square root of, this is 0, because I plugged in x is 0. So square root of c. So I square both sides, c is 25. And so my actual equation is y is equal to the square root of 2x plus 25. All right, on to some more examples. So this guy here, the first step of this is to rewrite the right side in terms of exponential rules. When we subtract in an exponent, we're totally allowed to just divide. So this is e to the x over e to the y. This is one of those guys back from Algebra 1. If you need an example of this, 7 to the 7th divided by 7 to the 4th is 7 to the 3rd because we subtract their powers. So we could write this as 7 to the 7 minus 4. So in a similar way, 7 to the 7 minus 4 equals 7 to the 7th over 7 to the 4th. So that's it. That's what's going on here. Now I multiply the e to the y's to this side, and I multiply the dx to the other side. Great. I am ready to integrate. Throw some integrals on here. I just get e to the y equals e to the x because turns out e integrals are really easy. So now all I need to do is solve for y. So I plus c. Now I just natural log both sides, and I get y is equal to the natural log of e to the x plus c. That looks great. All right, next problem. This is an example where the savvy first step is to divide y on both sides and move the dx over. So I get dy over y equals, if I divide both of these terms by y, I get 2y in the first term and 2x, in the first term, because I divided that thing by y and just 2x left, and then plus x squared dx. And now we're like home free. We're ready to throw integral signs on this, and we get natural log of y equals x squared plus x cubed over 3. Plus c. And this is so similar to the first example here. It's going to be the exact same sort of thing because we have a plus c, and we're going to e to the power of both sides to get rid of the natural log here. And so I'm just going to shortcut to the answer. It's y equals c e to the x squared plus x cubed over 3. All right, one last example. The last example is just dy dx equals y. It's actually the simplest example of the bunch. Well, I multiply the dx to the other side. I divide by the y. dy over y equals dx. And then I integrate both sides. And I get a natural log of y is equal to just x plus c. And so this is the classic example. If I e to the power of both sides, just like the last problem, I get y equals c e to the x. And this is our classic differential equation. So I wanted to throw it in here just to show This is the most basic kind of differential equation here. And I mean, pretty nice. And that's it for this video.